So for this one, we got the time limit exceeded. So if I go to details, you can see that it passed all the test cases except one. So the last one was probably very large input, and that was a time limit fail. For that reason, we are gonna go try to improve this. So the part of the code that makes it O(n) squared is computing left and max time every time over and over again, right? So for that reason, so let's try to think about calculating max at once. So for example, can we use like an array maybe to store the, so like we could, one way would be like using extra space, and yeah, one way would be, so let's say we have an array, right? So let's say we have an array, and this is our input array. So for example, at the 0 position, up to 0, so let's say, I guess the better way of doing it would be like, so if we start from 0, the max up to this point is nothing, right? So it's -1. So if we try, I guess it could be like, say 0, right? So try 1. So the 1, the maximum value up to 1. So the left side, okay, if you're at 1, right, you know that 0 cannot be. So what is the maximum value up to 1? The maximum value up to 1 is 1 itself, because there's not any other numbers. So how about at 0, like I'm just going through each. So here, the maximum value, since it's kind of like dynamic programming, it's a previous solution, right? So it's 1. So here at 2, the maximum value is the previous or the current, right? So it's like, so the maximum value looks like the maximum of the previous, which is I minus 1, map, I guess, storage I minus 1, and the current, yeah, so over here at 2, this would be 2 and 1, which is 2. So maximum 2 is itself. At 1, it would be previous 1, which is 2, or 1, but its maximum is 2. So at 0, the maximum would be, at 0 the maximum would be 200 itself. So in our case, it would be 2. At 1, it would be 201 itself, so it would be 2. At 3, it would be 2 or itself, so it would be 3. And at 2, it would be 3 or itself, it should be 3. And then at 1, it would be 3. At 2, it would be 3. At 1, it would be 3. So kind of like that. So this is the maximum for all the left value, for the left, right? Yeah. And so for example, for any index, I can tell you what's the maximum up to this point. So for example, at 0, there won't be any maximum, right? So we don't have to worry about that, because we're gonna start at 1. So yeah, and at 1, I know that maximum value is 1. At here, at 0, the maximum is 1. At 2, we can see that it's itself on its left. So I guess we could create an array left and left max and the array of right max, which would be in order to initialize it, it would be none values, or we could just put it like none times length of the numbers in array, which is the height, right? Height. Same for this one. Yes, let me just for the sake of an example, I'll just leave it there. Create another one, left max. So yeah, left max and right max. Now for the right max, how are we going to find it? We also have to do a for loop here. So for the left max, start at for I in range 1, start at 1 and then go all the way to height. So we kind of like win starting from here. So the formula, like I said, was, did I just delete the formula? Okay, the storage I minus 1. So basically the formula is left max is the maximum of, it's kind of like dynamic programming. So you're taking the previous value and then the current value and then taking the maximum of 2. So there would be storage I minus 1, and we're gonna take the current value, which is the height, and the height of I array. Yeah. So max storage I minus 1 and height, and I think so left max, and then we have to specify the index, right? Yeah, up to this point I equals to max, and then we have to do that to the right max, which is right here. So for the right max, we try and, so we start, I guess, from the end of the array. So let's see. So if we start from the end of array, apparently we're gonna start not from here. Since we start from here, same for this one. It's probably gonna start at this index, and we're gonna compare it. The formula for this one would be the maximum storage plus 1 and the current. So I don't have to go through example, but it should make sense. Kind of very similar, but it's just twisted logic, which starts in reverse order. Okay, so for J in the range, so the first one is stop, stop, right? So start at length of the height minus 1, which would be over here, and stop at where? All the way to the 0, right? So stop at no, stop at here. Stop at 1. Yes, 1, and then minus 1. So it's like it decreases. And right max. So J equals, so if you're at started here, we wanna, no, let's say we start at 1, right? We wanna get, no, we start at in here. Actually, we don't want to start at 1 because 1 wouldn't give us anything. Because at 2 we have 1 here, we can take the maximum of this 2. So that means that right max J would be equal to No, it would be like length height pretty close to 2. Yeah. So right maximum j would be equal to so the current, so it would be storage maximum of height j plus 1 and the current element, which is height j. And once we do that, we should be good. Yeah, and I'll test it for like, I'll print right max and left max. So I'm not sure what's gonna happen once it's gonna come down to like 0. If it's like the second one, I'm not sure how it's working. If it's working, I know how it's working, but I'm not sure if it's working correctly. So I'll put a left maximum and then the right maximum. I'll test it and see if it works. So I'll go ahead and delete this. I'll just go and run it and then see if it. So like, take this input and then paste it here. Oh, also this one, we don't need this storage. Okay, so non-type and so what are we doing? 45 non-times. Okay, 1 second. Length of the height. Oh, wait a minute. I was trying to. No, it should be like. Length of the height. Kind of like this. Yeah, should be similar. Okay, we have some problem here. Oh man, like, would you put a storage? Come on, that's just for an example. So as you can see, this is, we're doing it in order of on. So this would and we're doing it beforehand. Alright, so this is what we get. So like I said, at this point it is failing. So right here, the right max, all of these should be so what am I printing? So right max, even for 2 it should be 3, right? Okay, so it's not working correctly. The second one is not working. I'll go ahead and start printing the actual print J. So let me see. So we started at 10 and print J, and then we want to print height J plus 1 and height J. Okay, we have a syntax error. Oh, wait, what am I doing here? So looks like 10, 1, and 2. So we're here. 1 is height J plus 1, correct? Oh, okay, it makes sense. So 1 and 2. So at this point it would be 2. So that's what we have here, 2. Okay, now it's gonna go to position 2, and it's gonna take So it's gonna take the value. Like right now we're in here, so it's gonna take 2, which is correct, and the current itself, so 2 and 1, so it's gonna update it to 2, and now it's gonna go down to 2. It's gonna take the previous value, so I think it should not take. It should take the. Oh, we are using. Oh yeah, we should not update. Oh, okay. So right height. It's a maximum of. Should be maximum of j. So j plus 1, right? Okay, I think this should. So our problem is we currently using height, right? And we're updating the right max array. But then the next time we're using the height again. But we're not updating height though, so we have to use the right max. And this should be a right max too. And the thing is, and right max should be the exact clone of the height array, so this should be height, and left max should also be height, so we should not initialize it to like. So let's go ahead and run it and see what's gonna happen. So, and then length of the height, same thing, right? Yeah, so 10, 3, 3. Okay, 1 second. We kind of. So, copy array Python. So I think that was like shallow. Well, how to clone a copy a list. Your list was new. You don't actually have 2 list assignment. So yeah, this is like reference. You can use built-in list copy. You can slice it. So I think let's just slice it. So we're gonna use height. And also that's why we screwed up here. Okay, we are back to where. Okay, so this is a right max. At 0, we don't have any right max. At 1, it's itself. At 1, it should be 3, right? That's so this is not updating. It's not going all the way to here. Then I should say this should be not 1. It should be 0. That's where it stops, right? Yeah. Okay, cool. So great. It's working correctly. Awesome. So my mistake was this was 1, so it was stopping at 1, which is the index 1. But it should not stop at 1. It should stop actually at 0. So here we have 1, and the leftmost is 1 here, and 2 is 2 itself, and leftmost is 2. Okay, great. Now we should go ahead and I don't know how I could like just. What did I just do? Oh. Okay, it's working correctly. Now we have to, instead of having left and right, we should use we know the current element, right? So we have to use that. So basically when we are at 1, I'm gonna get its left. So I'm gonna get its left max is equal to no. So we're using the same variable name. left so far be equal to left max array, and the current is I, and then right max so far would be equal to right max, and this would be I. So once we have that, we're gonna take the 2, and so we're gonna take the minimum of left max so far and minus right max so far. So let's say we have to think about the case where the left max is a value itself. So let's say we're in here, right, and the left max in our array would be 2. So in this case the right max would be 3, so it would be like minimum 2, and this would 2 minus so minus the element itself, which is height and I, right? So 2 minus, so it could go to negative, right? So we're at 1, and then let's say we are at for example, let's say for this one we're at 1, and the leftmost here should be 1 itself. So here it's 2, so it would be takes 1 minus minus itself, which is 1, so 0. Okay, I guess total plus equals to minus min plus min. Okay, so let's go ahead. I think this should work, and let's go give it a try. So, and we can also get rid of this function. We no longer need this, and so we have, like I said, first we are copying list, and first we're calculating all the left max, right max, but we're using extra space, which is an array, and this would this trade-off here, because so let's go ahead and run this, and 4 and 6, so expected is 6, but we got 4. Okay, my assumption is probably true, so it's probably going to minus so it's just decreasing the total. So for that reason I would just assign it to like variable the trap. If trapped less than 0, if trapped greater than 0, then we would want to add it to the total. Let's go ahead and run it and see the output. Oh my god. Oh my god. So let me debug it right now. So the debugging part is, I'd like to say print left max and then right max, and we would like to print left max so far, right max so far, and we also want to print the element itself. This would help us debug it. Okay, alright, so there are no print statements over here. So the first thing is going to print. I think there are print statements here too. Yeah, I should get rid of it. Yeah, and this is just the Okay, let me see if it works. Awesome. So we have 0, 1, 1, all that, and okay, the first thing is 1, 3, 1. So 1 is the left max, so we're at the element, the index 1, and then the value itself is 1, and the right is 3. So 3, okay, correct, and the left is 1. Makes sense. So we're gonna go ahead and trapped would be minimum of left and right, which is 1. 1 minus 1. So we want to also print trapped itself. Okay, so 1 minus 1 would be 0, right? Okay, so if trapped it is not, so it's gonna go to the next one. So we're at the value 0, and we're gonna take the left and the right is 3, so we're gonna take the minimum, which is 1, and we're gonna take the minimum. 1 minus 0 is 1, so total right now is 1. We're gonna go to value 2, and the left is 2 itself, the right is 3, so we're gonna take the 2 minus 2 is 2 minus 2 is 0. Okay, we're gonna go to here at value 1, and the left is 2 and the right is 3, so 2, minimum of 2 and 3 is 2, minus 1 is 1. Okay, and we're at 0, and then the left is, okay, now check this out. The left, it says the left is 1. It should not be 1. So that's the part where I think our get left. So over here it's not working correctly. Okay, I see. So this is the thing I fixed in the right max, but I forgot to fix in the left max. I think we should, yeah, it's great, it's working now. Yeah, that was my mistake at the beginning. Also, it's good to change this back to left max, so it uses its own array, and this one to back to right max. So for debugging purposes in the console, try to use a print statement, but if you're coding on the board, it's good to go through this code through line by line with a test case, and come up with different edge cases that could fail your code. Let's try test it with custom test cases. So try make it like empty. So this edge case and edge case 0 works. Let's put 1 here. I think it should work too. So put 1 and 2. So when you have 1 and 2, should also return 0. Okay, we have 2, 0, and 3. This should be 2. Awesome. Yeah, this is the time complexity for this algorithm would be order of n, because doing O(n) of job, O(n) here, and we're also trying to, so we're using extra space to improve time complexity. For that reason, the space complexity would be order of n, where n is the number of elements in the height array. So that's basically it, and yeah, let's go ahead and submit this. Boom, as you can see, it's accepted. So we first came up with a brute force solution, and then we came up with a better, we improved our brute force solution by looking at the bottlenecks in our brute force algorithm, so that improved our, I think there's also a stack solution, but I'm not sure how to implement it. Yeah, we tried to implement stack solution yesterday, but yeah, but if you but I couldn't figure it out. But maybe I'll do it later, like time myself and then do it. If you haven't watched the previous video, make sure go watch that and then come to this one, because the best thing is first start from should not care about time complexity at the beginning. Try at least come up with a brute force solution and then try to optimize it. Yeah, and I'll see you later.